All right. So, well, that's the basis of the second derivative test, just looking to see if it's a positive or negative second derivative, positive being a local min, negative being a local max. But there are other cases that we can't ignore. What if, remember, since it's not in the screen anymore, I'll draw the first derivative test, and we're going to find that this function has a 0 right there. And then we take the second derivative, and at whatever point this is on the x-axis, we find that the second derivative is also 0. When that happens, the second derivative test is inconclusive. It doesn't really tell you if you have a max or a min, local max or min. So you're going to have to go back and use the first derivative test, which will not fail you. So you'll check on this side to see if it's positive or negative first derivative, and then you'll check on this side and conduct a first derivative test. So why is that? Why is the second derivative equal 0 not conclusive? Well, for one thing, there are second derivatives that if the first derivative is 0 and the second derivative is 0, you could have a function that looks like this, which we talked about. When that happens, the first derivative can be 0 and the second derivative can be 0. And that you can see as no max or no min. But you can't really tell because sometimes it'll look like this. It's a curve which has a very flat bottom to its concavity. So it comes down and has this portion that is flat. And something like y equals x to the fourth behaves like that. We used to say, well, that was another day. But y equals x to the fourth will fail the second derivative test. So y equals x to the fourth actually could be a local min, but the second derivative test will not pick that up. It will give you an inconclusive result. So you'll have to go back and use the first derivative test. So let me do an example, at least in theory, and you'll do plenty of regular examples when you get a chance in class. So let's say that the first derivative of this function looks like this. Say at -1 it equals 0. So remember, that's a critical point. And let's say down here 0, 1, 2. At 2, there's another critical point where the first derivative is 0. And then we'll go down to say 5, and there's another one. So we have 3 critical points. And we happen to know that the first derivative on this side is positive, negative, negative, positive. So what do we have going on here? And then I'll show you the second derivative and show that you can come up with similar information, confirming what you saw in the first derivative. Well, here we have a positive slope, and then it zeroes out, and then we have a negative slope. So right around here we have a sample of a maximum point here. But then around this point we have a negative slope, then 0, and then another negative slope. So here we have what I call a downhill rest. And around this point we have a negative slope, and then a 0 and a positive slope. So around this point we're going to have a local minimum, max, downhill rest, and minimum. All right. Let's look at a same example, and I'm going to show you what happens to the second derivative. And we're going to see that these are still the critical points are, well, we're not going to put those, here's where the critical point was, here and here. But what I'm interested in on the second derivative is the interval. So on this side we have a negative second derivative, and then at 1 we have a 0 second derivative, then we have a positive, then at 2 we have another 0 second derivative, then at 4, at 2, 3, 4 we have another 0 second derivative, and in between these two it's negative, and at 5 we have a positive second derivative. So this line traced what was going on with the first derivative. This line is tracing what goes on with the second derivative. So let's see if we can understand that and if it confirms what we saw up here. So in this interval we find that the second derivative is negative, and for a negative that's concave downward, so we are going to have a critical point here, so we're expecting a local max, just like we got from the first derivative test up here. Alright, here we have the second derivative zeroing out and then becoming positive. So it zeroes out when, as we talked about in the beginning, when the frown becomes, or this is the frown, and when it becomes a smile, that's when the second derivative zeroes out. And what did we call that earlier in this video? That is an inflection point. So we have an inflection point there. And now it goes on to have a positive second derivative right in here between these 2 points. So that means it's smiling, so we have the concave up. Then we hit a 0 in the second derivative, so that means that the graph is going to change from positive to negative. So it's going to start right around in there, it's going to start frowning, and then it's going to start smiling again. So do you see how this, in this section it was frowning, 0 was an inflection point, it was smiling, then this inflection point should be right under that 0, so I need to move it over a bit. That a little better there. Then it's frowning until here, where we have another inflection point and so forth. Alright, so we have 0 plus minus plus. So we have this kind of action going on. Alright, how does that compare to this? I see this matches. I see this matches. This should have been a downward. I think I should have traced this a little differently. So these aren't the same problem. I'm sorry. I tried to make it that this was identical to this. As you can see, this section was not described in these numbers. I'll try again on that another time. But for now, this first derivative will look like this, and the second derivative will look like this. All right. The part that I am not showing you is how to take a function and come up with these sections. But I think that you will be able to do that algebraically, and definitely when we get to class and you have your first several problems, we'll work together to show you how to get from an actual problem to the map that looks like this. Alright, let's call that a wrap, when we're going to end this video and bring this information about the first and second derivative to class. I haven't formally given you the definition of the second derivative, so I will do that in class, so you can add that to your notes right away when we get together on Friday. Alright, till then, just hold this together and I'll see you Friday. Bye.